Okay, how does this look? Good? How's this text? Okay, how does this look? Good? How's this text? Nice, okay. Hey, this is Zev. This is my first YouTube live. Sorry for any delays or technical projects, technical tech support type activities. Um, I'm jumping into a lot of assembly the last couple of days, trying to, well, more than the last couple of days. I've been reading a book about assembly, streamed a tiny bit on Twitch yesterday about it. Sorry, let me just make sure I'm recording here. Okay, it's recording. Sweet. Let me just put this chat here in case anybody pops in. Oh, how do I make this stay on top? Anyway, here's chat. I won't be talking the whole time. I'm learning as I go, but basically, I've taken a little detour. Basically, I've been watching this video from my favorite programming streamer, whose name I won't try to pronounce, and he made this, I guess, actually just a month ago, where he makes a web server in assembly, specifically using the flat assembler, which, as he explains in a long sort of exploration at the beginning, is less of an assembler and more of an interpreter, which, as a side effect, outputs binaries. But for our purposes, it's pretty close to assembly. So I want to walk through it and do what he's doing, but I also have a notion to document what he's doing a little with more detail than he does, probably for an eventual blog post. So what I have here is a virtual Ubuntu machine installed using Vagrant on my Mac. And I haven't installed the flat assembler. And there's a few other things I need to install, but so let's install Phasm. It's tiny. It's tiny, 343 kilobytes. I'm going to move this directory out. And I think I'm just going to do a quick and dirty symlink. Where am I? LNS home vagrant. That to user bin, user bin Phasm. So that's installed. He did like a hello world, which was pretty cool. Let's just jump back to that. This is the section that has the code. In a lot of assembly, I've seen it be reversed, where the data section comes first and then the code. Yeah, this is not exactly what we want to copy, but I'll see if I can remember what to write without looking. So he did this cool trick where, and apparently this is a feature of other assemblers. He did, oh, first of all, what does this mean? MSG is a variable name. DB is a byte. That's its type. It's a single byte. Does that make sense, though? This can't all fit in a byte. I don't remember. Message length is, I don't think it's a byte, but I don't remember what he put there. And then he did this cool thing. So what does this mean? It means $sign is the current line, but more specifically the memory address of the current line, minus the memory address of message, which gives you the length of message. So this is another variable. It would be nice to have some syntax highlighting, but I'm just gonna keep rolling ahead. And what actually goes here is a move call. He moves something into EAX maybe, or it might be EAX. Move it's not print, it's write. And what is the syscall code for write? I think it's something like 1. Move 1 into EAX. And then what it's going to do is it's going to do a syscall called write. But we haven't put anything in other registers for it to read as the arguments to write. So that's when we use the cheat sheet that he links to right here. Here's the write syscall. Oh, sorry, RAX. RAX is the register where you put the syscall code. And then the arguments to write there's 3 of them. The first is a file descriptor and RDI. Which is, I guess, DB. Sorry, message. No, that's what RSI is. What is the file descriptor? I don't remember. Unsigned integer file descriptor. I don't. Oh. No, I don't know. Move something to RDI. Move message into RSI, and then the size, move message length into RDX. Are there semicolons at the end of these? Seems not. Oh, what's this? 10 is a line break, or is it a termination? I don't remember. So yeah, let's look what he does here. Right. Oh. RDI is 1. Oh. Is the file descriptor of 1, is that standard in? Another cool thing he shows is you can make, I forget what he calls them. They're like compile time constants. Standard in equals 1. So you can do that. And then you could do this instead of the hard-coded constant. Standard in right. He explained this, but I don't remember what the 1 means.
Right. And that's it. So for that says that first argument of call is going into RDI. The second one is going to in RSI. To, I suppose, 6. 3 arguments we only. So what we need to move into RDI. We have to move the file descriptor. So the standard output is 1, if I'm not mistaken.
Standard right? Output. Oops. One is right. What's so cool is that you can actually make a macro so that this code can be self-documenting. And the syntax, I think, is there it is. No, sorry. Print. No, I can't remember that either. Macro, okay. Macro print fd buff len print standard out message len. D buff len. And then you also have to exit happy exit equals 1, I think. Exit 1, and let's make a macro for exit. And that's just oh, what was that? It was 40 or 60. 60. Move, syscall right one. Not sure, am I doing these right? Is this the syntax for making the compile time arguments? Just equals, I think so, yeah. Syscall right is 1. It's really nice. It's like code. Move syscall exit. It's the RAX. Kind of want to parameterize this to syscall register. Can you do that? Let's see. Oh, let's skip this for now. But also you have to do move exit happy exit code to RDI. I don't know if this is going to work. I'm probably missing something. But anyway, let's try it. Phasm, hello. It doesn't like something. Invalid operand. I didn't use any commas. It'd be nice not to have to, right? Anyway. Right. Okay. Missing all the commas. Move syscall right. Move syscall right. Yeah. Comma. Oh crap. Do you need commas or not? You do. Is the syscall prefix reserved or something like that? I doubt it. Macro print. Oh, I reversed it. I reversed all these. Unlike high-level assembly in this book I've been reading, the destination register is the first argument to move. Same problem here. Okay. Hello. It worked. That's sweet. And now I assume I can do this. Syscall register is RAX. Would that still work? Invalid value. Does it have to be a string? Would that work? No. Invalid operand. Compile time constant identifier. Compile time constant. Let's just look at the docs for that. Also, let me just see. I'm curious to know, is my stream working? Compile time constant. Let's just look at the docs for that. Also, let me just see. I'm curious to know, is my stream working? Compile time constant. Let's just look at the docs for that. Also, let me just see. I'm curious to know. Stream looks good. Is my stream working? Looks really good. Cool. And now I know that you can hear the YouTubes I'm watching, which is great. I am curious about this. I do like the idea of parameterizing the... Can you parameterize the register names? Compile time variables? Is that what they're called? Use variables a lot. Excuse me. I'm just going to abandon this idea. It's not that important. Okay, cool. So we've got our hello world. We've got some nice macros. I like how these describe themselves. Sorry, one more housekeeping thing. I want to keep this on top. How do I do this? If I do that, then what? There's got to be a better way to do chat. How do I get my chat back? Chat. I want this to stay on top. It's frustrating. How do you guys keep chat window on top? I can't go to Reddit. I block Reddit for productivity. Anyway, I'll check this sometimes, I guess. Okay, so I actually just want to follow along here, although, like I said, I do want to document this a little bit. Install Phasm. That's all we've really done. Oh, interestingly, I didn't have to change the permissions on the binary, whereas he did. I don't know what the deal is there. Just customizing my Vim a little bit. I swear I already did that. We don't need this. We can't use it. Okay. So the next thing he did was super cool. He created a socket and then stored the address of the socket in a variable. So move that to website server, let's call it. No, don't move it, copy it. Starting web server. he's exiting 0. Happy exit code. Oh, weird. I never used the argument. Because 0 is the happy exit code. So socket AFINet sock stream 0. The arguments to socket. Sorry, socket is another macro that he made. Macro socket takes the arguments domain, something, and protocol. The way he got the actual constants for AFINet and SockStream was funny. I actually want to recreate that or step through that.
With it. Interesting question. We can just look it up in the protocol. So after that, we're going to perform a
Type. This is called socket, which we don't have yet. Then we're just setting up the arguments. Oops. Name. Type. Protocol. And the way he even found out the signature of this syscall was, I think, man socket. Yeah. In this case, it's called family type protocol. And then it actually gives you some info here. Talks about AFINet briefly. SockStream. See socket 2 for more information on families and types. Where's socket 2? What is it? What's meant by that? Terminal is not fully functional. Why? Still says that. It's not a Windows problem. term equals x term. Great. Families. Okay. So the way he got the, where are we? Oops. Oops. What did I do? I just overwrote the exit macro. Syscall socket. $281, $198. Wait, which is it? What? 41, I guess. Domain type protocol, then call it. So that creates the socket. It turns out that what gets created by this is a file, or maybe a file descriptor. It is. It's a file descriptor. How do you find that out? How does he know that? Where's the return value to this thing? A bunch of options for socket. Return value of socket syscall. Yeah. A file descriptor for the new socket is returned, or -1 if there's an error. Sweet. And that's where I left off, more or less. He was about to handle the error case. But before that, by the way, is message length a byte?
Syscall. See? So the sense we need to somehow define net. I was trying to use this symbol in here, so that
oh, crazy. What? It seems that even so, this didn't cause an error that I declared this, but you don't have to declare the type. It's inferred, it seems. Let's just double check that. Yeah, still working. 3 passes, 237 bytes. The source is 517 bytes. The binary is 237. What he did was, what did he call this? Socket. Is there an integer type? I don't know. he starts debugging, and it goes quickly. It's the next thing to install.
That thing to bit right. So because if I accidentally do something like this,
sock file descriptor is a DD, which is a there's his cheat sheet. It's a double word. Yikes. Socket file descriptor DD, and it's just it's initialized to 0. DD is double word. DW is double byte. Is word for some reason. So okay, and then oh, and it turns out it's not obvious at all, but when this syscall is performed, I believe it stores the return value into RAX. Can we just print the value there instead of the debugger? Are we allowed to do that? Print standard out the value at RAX. It should be what's the length? 16? A byte? I doubt it's going to work. Wait, it did work. But it didn't print anything. Oh, yeah. Server and server. Illegal instruction. This wasn't illegal before. Oh. Okay, when I removed the type here, I didn't actually test it. I was testing the wrong file. He doesn't do it though. Why is he getting to do that? That's interesting. Anyway, what happened? AFI net. Ah, yeah. AFI net equals. He looked that up for us. It might be 2. And then socket stream is 1, I think. Segfault. I assume that's happening right here. Yeah. What? This just didn't do anything? print value in register. REX is actually a 64-bit value, isn't it? It's still just ignoring this. Okay. Segfault. Okay. So let's just do this. This is what he's about to do in the video anyway. Move to socket FD the value in RAX. And now socket FD len FB. Print socket FD socket FD len. Invalid operand. All right. Yeah, I'm lost.
I think it's gonna go over this entire thing and it will try to override this message, right? So it's basically gonna be buffer overflow.
Oh. Okay, I don't think I understand this syntax. You have to give it a type. Move double word. A double word would be, yeah, 64 bits, which is what RAX is. It's putting braces around it. They don't match. Oopsie.
Looks like we're live. That's the negative frags. We just provided bullshit in there, and we got a negative. It will work. So yeah, I'm gonna here. That specific entry. I don't freaking know. So
oh crap. EAX is where that gets plunked. Why? How do we know this? These are EAX is a register, or half of the space of RAX. A byte is 8 bits, a word is 16 bits, a double word is 32 bits. I think this would be valid. Let's see. If we said this was a quad word, DQ, then this would be valid, RAX. Yeah. But I want to print this. Why does it keep ignoring me? The length of a quad word would be 64. Why can't it print this? Okay, so equivalent to EAX if socketFD is initialized as a DD double word. As it turns out, on his machine anyway, the socketFD becomes the number 3, which fits easily into a byte. So if I'm not mistaken, then AX and maybe it's AL. Well, I'm taking this from another book having to do with high-level assembly, but yeah, AX is 16 bits, AL is 8 bits. I think this would also be valid. A single byte. Move byte socketFD AL. Oh, it actually tried to print it this time. And print, yeah, so let's try print byte. Let's make a special macro for that. just for fun. Yeah, in this case, I guess we want to zero extend this thing. I don't know. I don't remember how to do that. Oh, wait, it's move ZX, if I'm not mistaken. But I don't remember the signature of that. Okay, I'm going to backtrack again. Let's say this is a double word. A double word is 32. SockFD is a double word.
Standard output, which is 1, and standard error. So here I'm writing into the standard output, right? So this is a standard.
Oh, I've gone too far ahead. All right, let's try this debugging stuff.
It's quad word, right? So DQ. So this is sort of like a cheat sheet that I want to. I don't know what the fuck is that, honestly. So I can try to take a look at web or file. And it's just data, so you're supposed to, it's like, we don't really know what the fuck it is. So what if I do GDB? So file format not recognized. It just like uses some custom file format. I don't fucking know what it is. Right, so yeah, it's kind of difficult to debug this kind of stuff, right? And people keep in the chat confabulating different things. But there's one way you can debug that. The one way you can debug that. In ELF format, there's a very interesting thing.
Okay, I'm just going to install this debugger. Do I already have GDB? Maybe not. Nope. I think I'll be needing that. install GDB. These are just warnings. Wait, was this successful? No. Seven 7.5. running 18. Okay, just to call out what I'm doing, I want to be running a more modern version of Ubuntu. I don't remember why I set up a Ubuntu 18 machine using Vagrant, but I want an updated one. Then I'm going to get up to the point where I've gotten so far today with like a nice modern version of GCC, which apparently comes with modern Ubuntu. So how do I destroy this Vagrant machine? Vagrant, destroy. I don't think I have any other ones, but let's just make sure. Vagrant. I don't know. think I want this one. Yeah. Cool. Hey, if you're just joining, I am working through a cool YouTube of a stream from CSoding about making a basic web server using assembly language. He's using Flat Assembly or the Flat Assembler, which is something. I don't know much about it. It's basically assembly. You can write it. You can write assembly in it, and it'll produce a binary, and it has some niceties, some sort of high-level features like loops that are similar to HLA, high-level assembly language, from what I've seen from a book I've been working through. Anyway, I'm doing my development in a virtual machine, a virtual Ubuntu machine, and I'm just running into some problems and getting my debug set up the way I want, or the way he shows in the Ubuntu which I was running, which was Ubuntu 18. So I'm just setting up an Ubuntu 22 instance. I'll set it up as quickly as I can, and then we'll get back to what I had been doing, which is learning how to debug assembly code. So I'm in the machine now, and I'm going to clone a little starter kit that I made yesterday. Something failed. Do I have GH? No. So what failed here? Well, I guess this sort of worked. I have GH now. GH off, login. Okay. Note to self, rotate my GitHub token probably right away. Okay. My screen's blank because I'm getting a new GitHub authentication token and invalidating the one I just exposed. Where's this stuff again? Bye-bye. That token is gone. Okay, got a new token. Deleting the old one from 1Password. This time I'll store it as a login so it doesn't show. GitHub auth token. Okay, great. We're back. Right. I didn't strictly need that. But anyway, git clone, github.com, learn assembly, cd learn assembly, cd, this is where we were, steps. Okay. What version do I get here? Oh, 11. Perfect. Come on. Oh, amazing. It actually worked. Oof. Okay, here we go.
It is called format, in ELF format, there's a very interesting thing. It is called format. In ELF format, there's a very interesting
Read elf. Cool.
Thing. It is called entry point address. It is called entry point address.
So funny. That's so cool.
So what you can do, you can break on that specific address that you found in the ELF file, and then you can run this entire thing. But you're not going to see anything. You're not going to see anything. So you need to enable, and you need to set as layout to assembly. And there you go. So here are all of your syscalls. But you see the pure assembly, right? So you see the raw assembly.
It's amazing.
To enable. But what you can do, it's called entry point address. So found in the ELF file. And then you can run this entire thing. But you're not going to see anything. You're not going to see anything. So you need to enable, and you need to set as layout to assembly. And there you go. So here are all of
My terminal doesn't support this TUI, it seems like. Okay, so we'll save this and let's get out of here. Let's try the Mac terminal, I guess. Vagrant SSH. God, this feels slow already. Ooh, wow. GDB server. Oh, server. Good point. Okay. You can use a TUI on good old Mac terminal, but not Kitty. And the developer seems a bit hostile. Layout ASM.
Enable, and you need to set as layout to assembly, and there you go. You can run this entire thing.
Didn't run it.
But you're not going to see anything. You're not going to see anything. So you need to enable, and you need to set as layout to assembly, and there you go. So here are all of your syscalls. But you see.
Wait, what?
Thing. You're not going to see anything. So you need to run this entire thing. But you're not going to found in the. You can break. So, what you can do, you can break.
I didn't run it. I didn't realize you give it a running file. GDB server break there, run. Why is this happening? Oh. Server isn't there, but it didn't tell me that. Awesome. Run. Layout. Assembly. Wow. That's sweet.
So you need here are all of your syscalls, but you see the pure assembly, right? So you see the raw assembly, but you can see the syscalls in here.
So let's see. That's the first print call, maybe? It's cool.
Here, you can literally see the syscall in here. So apparently FASM comes with its own kind of thing, but it's kind of difficult to figure out like right off the bat how to use that. So I'm probably not going to use that. So this is the trick that kind of works. So maybe I'm going to work with that trick. We can actually use a better, debugger, right? Why do we have to use GDB if we can use something like GF? Right, so I'm going to be GF.
Kind of like this font. Right. GDB, binary. And when you do that, what does it say? run to enable layout assembly. It's so cool. It's awesome.
And I'm gonna do website. So let me see. So
Damn.
maybe I'm gonna be GF, and I'm gonna do website. So let me see. So maybe I'm gonna do it like that.
Well, I guess I won't be using that.
And we're gonna break specifically on that thing. So can I find the entry point? So I probably can just, highlight. Can I put it in here? No, I can't put it in here because GF doesn't really support that. Doesn't support inserting it like that. There we go. So maybe this is something that I have to contribute in there, right? So I can run it now, and there we go. So, and the cool thing that you can have in here is that you can quite conveniently see the registers, especially if you step, right?
Info registers.
So as you can see, I'm setting up different registers. right? And then I perform the syscalls. And as you can see, after performing the syscalls, I have a starting web server. Right, and after that syscalls, we have a couple of things modified in here. So, and you can see that rags became 21, right? So essentially, write syscall returns the result in rags. It returns the result in rags, and it usually returns the amount of characters that were written into the standard output, into the file specifically. Standard output is just a file. So, and if we take a look at how many characters we have in here we have 20 characters.
In hex, 29 is 41. Why? 2, 3, 4, 5, 6, 20. 21 should be 21.
Specifically, right, 20 characters specifically plus the new line 10, right? And this is exactly what we see in.
Wait. Oh. Advanced too far. What am I looking at? You step back. So right now the value of RAX is 1 because that's the syscall. It's right. And now the value of RAX is eight. Is it hex or binary? It looks like hex. But that would be a very large number. What's the first instruction? The first thing we're doing is print. And print moves 1 into RAX. Then it calls write, and write should put into RAX the length of the thing it just wrote to standard out. Or what it wrote to whatever. Six, 7, 8, 9, 10, 11, 12, 13. Should be 21 characters, which in hex would be F5. I don't get it. Oh. If that's a hex number, it's gigantic. It's 16 squared. Yeah. Times 8. It's 2048. I don't understand this. Okay. Oh, right. So now this value has been moved into RAX. It's another syscall. I think that has to have been the socket, because now our RAX is 3. Yeah. Okay.
And RAX 21 characters, so the Linux kernel told us that I wrote 21 characters. So we can literally see all of that, which is pretty convenient. Right, so the next syscall is supposed to be a what? I forgot. I think it's a socket. All right, so let's actually set up the socket. Boom, boom, boom. And we are about to perform. Is it really correct, actually? So I have a net 2. It doesn't really feel correct. Because there is 4 things in here. Oh, syssocket, yeah, so syssocket is 41, which is actually, yeah, so everything is correct. So what's going to happen after the socket? So the result located in rex is 3, which is a really plausible number for a socket, right? So because basically by creating a socket, we created a new file, we opened a new file. We already have 3 files opened with ID 0, standard output, standard input, with ID 1, standard output, and with ID 2, standard error. So if we open another file, so the ID is going to be the next one after that, which is 3, right? And that's what we get. So we have the ID of the socket, the file descriptor of the socket in rex. And essentially, like, we don't really do anything with that thing, right? So we just populate the arguments for the exit syscall, and we just exit. So I suppose what we have to do, we have to save that socket ID somewhere, right? We need to save that socket ID. So let me see. So let's create something like sock of D. How much memory should we allocate for storing the socket ID? How much memory should we allocate? So I mean, maybe 4 bytes is going to be enough. So I know that the directive db is byte, right? So this is 1 byte. Word 4 is going to remember that. So I can only remember that by sort of like doing this mnemonic, right? I know that byte is 1.
I can't get over the fact that this thing fails if I take away this. What's the difference here? Start. Message length. He doesn't. Oh. Damn. You need the equal sign in order to calculate something from another variable. So this should work now. Okay, great. Mystery solved.
And word is 2. So that means 4 bytes is double words and quad word is 8 bytes. So we can just do dd, right? And you're supposed to put the value of this thing in here. So I'm going to put 0 in here. There we go. So, and essentially what we can do, after we call the socket, we know that in rex we have the file descriptor. We can just move the file descriptor into here, right, from rex. But we have to be a little bit careful, right, because it's 32 bits. Rex is 64 bits. So maybe we want to do EAX, right? And as far as I know, FOSDEM also supports the syntax where you can literally say dword, indicating that do the 32-bit right. So because if I accidentally do something like this, I think it's gonna go over this entire thing and it will try to override this message, right? So it's basically gonna be buffer overflow. Right.
I just realized I haven't been compiling this when I make changes. Oops. Okay, it's still working.
Going to be buffer overflow, so we have to be careful with this kind of thing. So it has to be dword, and if I remember correctly, if you do it like that, FOSDEM is not going to even warn you about that. Oh, it warns. Operate size does not. Okay, so it actually warns you if like some write sizes and read sizes do not match. It's actually pretty cool. So I have to do dword instead, and it works, right? It works, and it will save it there. We can now check if it actually worked out. So let me see how to do that.
Yeah, and I want to look at this because I don't know what these braces mean. I assume what ends up happening is that the value that's in EAX gets stored in socket FD. And without the brackets, I don't understand what would be stored there. So I don't know. Let's see if I can make any sense of this. Oh. Whoa. What? I'm a bit lost.
So, yep, I'm gonna try to refresh this entire stuff. And unfortunately, that kind of killed the breakpoint. Let me see if the breakpoint is still there. So I'm gonna do read elf e. Right, so entry point is this specific thing. So I'm gonna break on that specific point, and I'm gonna just run this entire thing, and there we go, we're there. So yesu. So here is the move, by the way, I think. No, it's somewhere down below. Did I do that correctly? I cannot find this instruction. I can't really find this instruction. So here is the right. Okay. Oh, I think it didn't update the executable. It uses the old executable because there is this socket syscall, and then instantly the exit syscall. I think I need to actually refresh everything. So I'm going to try to recompile, and I'm going to just do this thing one more time. So gf2 website like this. Do I have break? No. So I wonder if there is some sort of a way to save that specific entry point, but I feel like it may change if something changes within the executable, right? So maybe some things get offset or something, so I'm not really sure. There we go, so here is the right. You know what's cool in here? Right, it uses a relative.
Let's look for something like that, I guess. There it is. Okay. This is an offset from the current memory, and it calculates to that. That's the actual memory address. But what is this? It should just be 3. Anyway.
Address, right? It's relative to the current instruction pointer, right? So basically here's the current instruction pointer, here's the current instruction, and it's plus this specific value. But JDB has a very cool feature. It gives you like the absolute address. It gives you the actual absolute address. Right, and we can use that as a pointer. So we can literally say 4102, and I can say, okay, let's cast that to the pointer integer. You can do that, right?
Really?
In GDB. So this feature comes from GDB, and then we can dereference this thing, and it shows us the value of this thing. We initialize that variable with 0 in here, right? So it's with 0, and as you can see, it is 0 in here as well.
Get value address. Oh. PX. Oh, that's what I've been using. 0x. No, it doesn't help me. What's FC? XS? Oh, there it is. That's pretty cool. What's XS? Oh, a string. I gotta take a break. All right, let's keep going.
Well, so that's pretty cool. So let's actually do step debug. So here's the write. So we wrote starting web server, and then we are creating socket, right? So if we take a look at the registers, we'll see that in here, in the register, in the result, we have 3. So, and we are about to write that 3 into the memory, into that little section of memory that we allocated specifically for storing the socket. And there you go, it actually wrote it there. So if you know the specific address of your variable and you know the type of the variable, you can just use this kind of trick and you can literally see it in the debugger. So without any...
I want to try to cast it like that.
this kind of trick and you memory at the register. Right, and we can use that as a pointer. So we can literally say 4102, and I can say, okay, let's cast that to the pointer integer.
Still not an integer.
You can do that, right?
No.
GDB. So this feature comes from GDB, and then we can dereference this thing, and it shows us the value of this thing. We initialize that variable with 0 in here.
Oh, that worked. Sweet.
Right? So it's with 0, and as you can see, it is 0 in here as well. So that's pretty cool. So let's actually do step debug. So here's the write. Look at the register. 3 little section of memory that we allocated specifically for storing the socket, and there you go, it actually wrote it there. So if you know the specific address of your variable and you know the type of the variable, you can just use this kind of trick and you can literally see it in the debugger. So without any debug information, I can already explore different variables and stuff like that. So that's pretty cool. Cool. I stored the ID in the memory. I stored the ID in the memory. So people asking what is the GDB frontend is actually called GF. So let me give you, yeah, there we go. So let's go ahead. Let's take a look at the registers.
Right. So now he's going to intentionally make this be equal to -1. Exit if socket FD equal to -1.
Still using the old. Yeah, it doesn't refresh. I remember if I press, yeah, it restart GDB, but it doesn't really. And let's take a look at the rax in here. Rax should become like, yeah, there we go. So that's the negative rax. We just provided bullshit in there, and we got a negative value. Right. So we got a negative value. So I suppose what we have to do, we have to check for a negative value. So the way we can do that, we can do probably right after we did the socket, we can do CMP rax 0. All right.
Wait. I thought Rax was going to be 3.
And for example, if it's less than 0, we have to jump somewhere, right? We have to jump somewhere. For instance, we can jump to error, and in error, we can have a separate thing in here. So error is sort of like a separate section, right?
Okay. Jump if less than.
And here we're gonna maybe print an error message. So maybe we're gonna do error mcg error mcg len, and then we can say mcg len, and then we can say so let's rename start with error mcg, boom, error like this. There we go. So, and after that, we probably want to exit with non-zero exit code with 1. To be fair, maybe we want to even write it into the standard error, right? So, and to not actually work with magical numbers, one of the things we can do, we can just define things like standard output, right? So this is a standard. Write error message and exit with 1. I don't freaking know. I don't freaking know. So, all right. So if I do something like, yeah, let's actually repeat that. But now, instead of just compiling it, let's also run it and see if it will say error. There we go. Starting web server, error. let's actually and see if it will say error. There we go. Citing web server, error. Error. So instead of just compile, all right, so if I do something like, yeah, let's actually repeat that. But now, so that's pretty cool. If we get back to like the correct arguments, yeah, it actually started. It actually started. So that's pretty progress. So people also suggesting to do something like exit success and exit failure. We can do that. Why not? So just to make it even more POSIX compliant, exit success 0, exit failure 1. So as far as I know, using equals means that this is like a compile time variable. So that means at compile time it can change, but this is not particularly true for these kind of things. They are more constants. If I remember correctly, in FASM you use EQ instead of equals to indicate that this is a constant, and that way they cannot be changed. The same kind of goes in here as well. You just do EQ, and this is a compile time constant specifically. This is a compile time constant. Same kind of goes indicate that this is a constant, and that way they cannot be changed. The same kind of goes in here as well. You just do EQ, and this is a compile time constant specifically. Compile time constant specifically. And I really like how like easy it is to check for an error, right? So it's just like two instructions, like compare to 0 and just like bail out to the error section, and there you go. And if everything is successful, you just save this socket file descriptor. You just save this socket file descriptor, and now you can work with this specific socket file descriptor. So that's pretty cool, I think. But the problem here is that it's not particularly clear what's the cause of an error. What's the cause of an error? One of the things we can do, we can basically, before performing any of the operations like socket, bind, listen, accept, we can just log what we're currently doing. We can just log what we're currently doing. We can do something like write std out socket trace message. That's pretty long, but maybe it's fine. Right, socket trace message, and essentially instead of start socket trace message, creating a socket, right? Creating a socket. So socket trace message, socket trace message that, blah blah blah. There we go. And if I try to run this entire thing, start len. There is no start len. Ready? Undefined symbol. So it is in 45. It says there is no start len, but this is not true. Huh? Is that because I still have to use equals in here apparently? Specifically here, so all right, okay, so creating socket. But if I go back and fabricate an error, 69420, yeah, so we know at which point the error sort of occurred, so we kind of roughly know where it occurs. So starting web server, creating a socket, and an error. So maybe if there was no error, we want to say something like okay, so okay message, okay msglen. All right, so there is a start, and then we're gonna query replace start with okay, boom, okay web server. Okay, right, so that way, so okay message I didn't see it because I'm supposed to call it like this. Let go. So undefined symbol okay, so because it's an okay message, boom. So yeah, error. But if we go back and get rid of an error, just create a socket, it says okay. So now we are able to trace each individual sort of action, and if an error happens on some sort of action, we know where roughly it happened. So it will help us a little bit. Hopefully it will help us a little bit. So yes, we can even like maybe prefix all of these things within for to make it look like a legit logging, right? Because all of the logging frameworks, they have this sort of like a levels of logging, like info, warning, and error, and you feel like very enterprise. You feel very legitimate, very serious. There we go. We have different diagnostics at different levels. We can actually tweak the level and only focus on very specific problems and not waste time on other problems. You feel really good about yourself when you're using logging system like that, don't you? I think you do. So that's literally the only reason why people have that. So, and there we go. Look how fucking cool it looks. You just put a simple prefix in for, and it already looks legitimate. It looks like a serious program. Can you believe this shit?
Wait, how'd you do that?
And there we go. Look how. That's literally the only C#. You can only do that in C# and not in any other language. It is impossible. But we're gonna tackle that. That is not going to stop us. The only thing we need is a cup of tea. So yeah, let's make some break. All right. I'm back with my tea. Mighty tea. I mean, I was trying to say mighty tea. Okay. Not what you thought, okay? So,
all right, so the only remaining mystery for me here was these brackets. I was like, I know what this is doing. It's moving the value stored in EAX, the EAX register, to this memory address, socket FD. And that's exactly what the brackets mean. Socket FD, when it was created here, where is it? Here. It's initialized to the value of 0, but what it actually contains, what it actually is a pointer to a memory address. So this is saying store the value in EAX in the memory address referred to by this variable socket FD. I guess another thing to make explicit is, why does this type need to be here? Why can't it just be like, well, EAX is a 32-bit register. Can't it just infer that it should store this as a double word here? I actually don't know how to answer that. I guess the answer is there's less magic in assembly. I think in C you could get away with this, although in C you're not dealing with registers directly anyway. We do have another move. We have other moves here, right? Dealing only with arguments and registers with no types declared. I think it's because we're dealing with memory here. That's when you have to be explicit. That's my best guess.
What we need to do, we need to allocate a little bit of a memory for the structure. So first of all, we need to understand what kind of structure we have to allocate, right? So if we take a look at the definition of bind, so we have a structure sock adder. We can try to find the definition of the structure. I don't really want to search for the definition of the structure in my local source code because it's kind of difficult to find anything in there because it's like a glibc. You know what we're gonna do? I have an idea. What if we just like download something like Musel, right? And we're gonna grab Musel for implementations and stuff like that, right? So some other people may say, but that's cheating. To that, I can only answer, I cheated with your mom. I can do whatever I want. It's still gonna be website written in assembly. Whatever I want. It's still gonna be mom. I can do.
Can't see that.
Do whatever I want. It's still gonna be website written in assembly. Still gonna be website written in assembly. All right, so I'm gonna be using that as a reference. I'm an artist. I'm a performance artist, right? And this is my reference. You know how the artists like look up pictures on the internet for reference and stuff like that. That's the same thing. That's the same thing. It's a reference, and I'm an artist. So yeah, so let's try to find the definition of this specific structure, right? So if we take a look at the bind, it's probably defined with open curly brace, right? So we can do something like this. So it's going to be like that. Boom, here is the definition. This is the art of grepping.
Cool. Super cool.
The art of grepping. So knowing what exactly to grep to find precise place where the shed is located without any, IntelliSense IDE or anything like that. You just like craft a specific combination of characters and boom, you found it. And it's language agnostic. It is language agnostic. If you know how your language works, you can do that with a simple grep, and there you go. You find the definition. It's that freaking simple. And it's going to work 5 years after today, 10 years after today. Will your favorite IDE survive after 10 years? Will you be able to still use Visual Studio Code in 10 years? Will it still be there? Or maybe Microsoft will go bankrupt and this entire thing is gonna die. We don't freaking know. But even grep does not survive in 10 years. There will be some other tool that accepts a string and just searches for the substring in the file system. And that approach is going to work in 10 years, in 20 years, in 50 years. That's it. Anyway, so that's basically the structure. And that's a very interesting structure, right? So that's a very interesting structure. It has subfamily and subdata. Subfamily and subdata. But if we take a look at the example from the very reputable website called Geeks for Geeks, right? Very reputable website. They actually have 3 fields in here, which is like, what the fuck is going on in here? So what's the definition of server ADDR? The definition is actually sock address underscore in. Wait a freaking second. If I take a look at the definition of the bind, it's ADDR without in. But here we do in. What the fuck is going on? What the fuck is going on? We can try to find the definition of such thing. Of course, we can just put in there. And it's completely different. So there you go. So it has scene family, scene port, scene address, and some scene 0 to, I suppose, pad that specific thing to the size of sock address without underscore. And they also, furthermore, when they pass in this pointer, they actually casting that to a very specific thing. So we are using a different structure than the one that bind expects. And this is because this is a form of polymorphism. So essentially, you can create sockets of different domains like internet domain, Unix domain, and stuff like that. And bind is supposed to work with all of the sockets regardless of domain, right? And different domains may have different sort of parameters. So underscore in indicates that we are operating within the internet domain, and these are the parameters of the internet domain. So as far as I know, there's also UN, I think the UN. So there is a similar sock ADDR, but with UN, and this is for Unix domain. Maybe it's actually located somewhere here. Yeah, there we go. So, and to be fair, I think they have different sizes actually. They actually have different sizes. So I thought that maybe 0 was added to pad to a specific size, but it's not necessarily true because for Unix domain it's actually huge. Look at the size of this specific socket. Look at the size of this specific socket. And I think this is intentional, right? If we take a look at what's going on here, bind also accepts the size of the structure that you're passing. It also accepts the size of the structure that you're passing. It distinguishes the kind of the structure by its size that you pass. But what's interesting is that Unix is not the only thing that does shit like that. WinAPI does stuff like that all the time. Do you guys remember like the usual sort of pattern in WinAPI where you create a structure and within the structure there is a field into which you're supposed to write the size of the entire structure? And they actually use it not really for polymorphism but for preserving backward compatibility when they extend the structure. Right, because you can have a user code that expects a very specific size of the structure, so it limits how much they can change that structure. Right, and because of that, they force you provide the size of the structure so they know what version of the API you're using without modifying, recompiling your code and stuff like that. So it's kind of like all over the place in C world. Right, and it's nothing particularly new. Right, and it's like this kind of stuff is in the level of the kernel. It's in the level of kernel. Very interesting. So anyway, what we want to do, we probably want to take the definition of the structure, right? So let's actually take the definition of the structure and maybe copy paste it somewhere here. So I'm gonna That was really strange. I thought I managed to copy paste it correctly, but I didn't, because I'm a dummy dum-dum. Okay, so we need to know the sizes of these fields, right? So we have these kind of fields. So this is port, family, port, and address. So what is a scene family? So it's defined somewhere here. Subfamily. We don't really know the size of this entire thing. So maybe we can do something like this. Can I just do that and see? Or maybe I can just find the definition of this stuff. Maybe I can just find it. So let's actually go ahead and do that. I'm gonna do grep rn, and it's probably something like
It's an unsigned short. What's a short?
a type that to find anything from grep. The fuck is it? It's even not like a C. It's an input to some sort of a preprocessor. Freaking. So usually the files that end with .in, they're input files for some sort of a preprocessor. So that means it's not the final file, it's like generated. Maybe depending on the platform, it could be generated differently, but anyway. So short is unsigned short, so that means it's 16 bits, right? So this is what we know, for what we know. Right, so this is basically 16 bits. Cool. So the next thing is, so in.h, import, another 16 bits, right? So all of them are essentially 16 bits. 16 bits. And what about that one? In address. Okay, so this one is a structure. All right, so this one is a structure, but it's a structure of a single field, and that field is actually 32 bits. Okay, so we don't really need to create a separate structure. We can just say that this is a 32-bit integer, right? So that's the easiest thing to assume in here, like 32 bits. And in here we have 8 bytes, and 8 bytes is 64 bits, right? So essentially, if we allocate, you know, it's kind of funny that these 3 fields add up to 64 bits. Right, it's just basically 2 64-bit numbers, right? So it's pretty straightforward. It's pretty straightforward. So let's take a look at this thing. So they allocated server ADDR, right? So they allocated server ADDR. So maybe I'm gonna keep like all of this string information like here, and all of the actual data is gonna be located in here, right? So the actual data. So serve. So how did they call that? They called it serve ADDR, serve ADDR, and we're gonna have scene family, right? So this is a scene family, and 16 bits is a word, right? So this is gonna be like this. So then we have a port, which is another 16 bits, and then we have ADDR, which is 32 bits, which is a double word, right? So DD, and then we have a little bit of a padding. And I think I'm going to respect that padding. So we're going to have scene 0. And I can just use DQ, which is basically 64 bits. And, you know, is it really true? 8. I'm pretty sure it is, right? So 8 multiplied by 8, 64. Okay, so I had a little bit of a brain fart. I do remember how the math works, okay? Just had a little bit of a brain fart. So, and the next thing we can also define is something like size of serve ADDR, which is equal to current address minus the beginning of this entire thing. Right, and this is basically how we can allocate this specific structure. I think it does make sense, right? I think it does make sense. That's basically what it is. Yes. So maybe I'm gonna even put this definition on top in here, so it is kind of relevant. Maybe we're gonna even use the FASM struct thingy. Maybe we should use a FASM struct thingy, but I'm not really sure how exactly we're gonna do that yet. Anyways, so let's start populating things. We need to do this kind of stuff, right? So that means we need to take this stuff, right, and dereference this specific pointer, because when you refer to the name, you're referring to the address where that specific field is located. You're referring to an address. So in FASM, in Intel assembly, by dereferencing, you just put it in brackets. You're effectively dereferencing this thing. Right, and what we want to save at that specific address, we want to save IF inet. But you have to be very careful, right? So because you want to do 16-bit right, so we want to say it's a word, right? So you want to say it's a word. Okay, and this one is very interesting. Okay, so here you have to provide basically the address, right, in the network order. So as far as I know, the order in x86-64 is the least significant byte, right? So, and the network order is actually most significant byte. And because of that, we have these sort of functions that revert bytes when necessary. So I know for sure if you are on x86-64, you always need to revert the bytes, right? So it's a little big engine. Yeah. So chat says little big engine. So as far as I know, in case of in ADDR any, you don't really have to do anything much, right? So if we go here and I say in ADDR any, I think it is equal to 0. I think it's straight up equal to 0, so we don't even have to worry about that. So let me see. So
he did this cool ass trace stuff before. I forgot about that.
ADDR any, so maybe we need to include additional stuff. I don't really remember what kind of stuff we have to include. So let me see what we include in here up there. So we have socket. Maybe we need to also include additional these things, net db, net inet in.h and stuff like that. So there we go. We definitely need this kind of stuff. Oh, it's 0. There we go. So, and 0 is represented by, all bytes being 0. So it doesn't really matter if, like, what is LSB or, MSB and stuff like that. It doesn't matter. So 0 is 0. 0 is 0. So because of that, and then I think we can just use it as it is. So this is going to be like that. Move. But in our case, the name of the field is just syn ADDR. Yeah, it is syn ADDR, so we need to do it like that. And ADDR any, there we go. So, but what's the size of this thing? It's 32 bits. It's 32 bits. Okay, it's kind of interesting. Why are they filling them up in kind of a weird order? Because after that you have a port, not the address. But anyway, so it's just geeks for geeks, am I right? Right, so geeks for geeks. After family, you have port, and then you have address. But they actually filling it up. Jesus. All right, so this is going to be that. And the size of this thing is actually double word. So it's a D word, right? It's a D word. Right, and then we need to say the port. Okay, and the port is going to be interesting. So I want the port to be 6969. But I can't really do that because it has to be, the bytes have to be in a reversed order. So I either have to implement htons, which I don't really want, but I could, but I don't want to do that. What we can do, in fact, we can do an interesting trick. So let's actually take 6969. This is in a decimal representation. Let's actually turn it in hex. Hex has a very cool side effect. It's basically one of the reasons why people use hex. So the reason why people use hex is because the specific bytes of a number are visible. Each pair of byte in hexadecimal representation is a byte, right? So basically this number is represented by 2 bytes. The first one 1b and 39. So if you want to invert the order of bytes, you can literally do the following thing. And there you go. So this is essentially in a network order. So you can just like manually swap them, and this is the value that you basically have to put in the port. And it's going to work, right? So that's why people use hexadecimal representation, because you can see individual bytes, individual nibbles, right? So some people say that 4 bits is a nibble. Yeah, so you can, like, each digit in hexadecimal representation is a single nibble, which is 4 bytes. And so 2 of them is 4 bits, so 2 of them is 8 bytes, a single byte. I keep confusing the terminology, okay? So I'm a little bit tired, but you get what I mean, hopefully. You get what I mean, hopefully. Anyway, so let's actually save this value to that specific field. So this is going to be worked like so. There we go. And we just filled up the entire structure. So I actually want to preserve the order as it is in the memory, right? Because in the memory, first we have family, port, and address. A 0, we're not going to put anything in there. It's basically the padding to preserve very specific size of the structure, I suppose. Very specific size of the structure, so that's fine. And yeah, there we go. We filled up everything. So the next thing we need to do, we just need to call bind, right? So we need to call bind. So in bind, in our case, it's going to be sockfd. We already have sockfd located in here, so we're reading it and putting it in here. So now we have to provide the pointer to the serve address structure. So what we're going to provide, we're going to just provide the scene family, because this is the first field, so it points at the beginning of the structure. So by pointing at that specific field, we point at the entire structure, right? We just point at the entire structure, and then here we provide the size of this entire structure. So that's basically it. So, and after that, we may also like to check for errors, check for potential errors, right? So in case of an error, we're gonna go to the error handling code and just like do it like that. So that's pretty cool. It would be also nice to maybe write a message, right? Something like write std out, and here we're gonna have, maybe I'm gonna even copy paste that specific line, and I'm gonna replace socket with bind. So now we have a bind trace information, right? So first we're saying what's the action we're doing. We're filling up the structure that explains what kind of socket we want to have. It's an internet socket at the port 6969 that accepts connections from anywhere, right? So because it's all 0. Then we perform the byte and then check for the error and so on and so forth. So, but the thing we need to have the bind macro, right? So we didn't create the bind macro yet. So let's go ahead and do that. I think that would be very beneficial for us and potentially the humanity. Who fucking knows? I don't fucking know. Probably not. Nothing I do is beneficial for humanity. Beneficial. So, but the thing we need to have the bind macro, right? So we didn't create the bind macro yet. So let's go ahead and do that. I think that would be very beneficial for us and potentially the humanity. Who fucking knows? I don't fucking know. Probably not. Nothing I do is beneficial for humanity. So here are the parameters. So sockfd, addr len. There we go. So let's do move rex sysbind. So we need to know this thing. Move rdi sockfd, then rsi addr rdx addr len. So we have a lot of repetitions in here in how we do the syscalls. Maybe in the future we're going to define a bunch of macros, things like macro syscall 3. Doesn't it remind you something? Doesn't it remind you something? Right, where we could maybe even like a number and essentially do it like that. Number and then A, B, C. Right, and when we do bind, we can essentially do syscall 3, sysbind sock of D, ADDR len, and like that. So yeah, people say port exactly. So yeah, and you can predefine like different syscalls and stuff like that. I'm pretty sure maybe you can even make this number a parameter of the macro itself, and maybe you can sort of switch case based on that or something. I don't really know. We're also kind of nice to explore if macro system has variadics. So, and basically do not pass this thing at all. But I mean, syscall is already taken, so we'll have to call it somehow differently. But that's an interesting idea nonetheless. Yeah. It's an interesting idea nonetheless. So then we perform the bind, and so we have a bind trace. So we need to replace socket with bind, and here say binding the socket. There you go. Binding le socket. Okay, so can I just now compile this entire thing? So I'm going to do FASM, website ASM, no, FASM, FASM. There we go. So let's go through the compilation errors. So operand size do not match. Okay, that's very interesting. So it's at the 38. It's at 38. Oh, that's very interesting. Is that because when we do sock of D, we have to... Ooh, this one is interesting. Because it's a double word, and we're okay, I see. It's a double word, but we're saving it to 64-bit register. So what if we just do DQ and make it 64? Right, and every time we sort of like, yeah, I think that would be better. That would actually solve the problem. So let me see. So we bind, this is 64, and here I will have to use racks in that specific case. And this is a keyword. Yeah, that would be better. It's actually kind of cool that it checks the sizes. I thought it doesn't check them. Yeah, all right. So it kind of checks the sizes. So undefined simple in address any. Did I define it really? I didn't define it apparently. Okay, so that's fine. So let's say that it's going to be 0. It's supposed to be 0. Undefined symbol sysbind. So let's actually define it. Sysbind. So the error messages are reasonable enough so far. I'm really glad. So let's find the bind thingy. 49. Okay. There we go. So do we manage to compile this thing? And it please successfully compile this. Is it not a poggers, meine Freunde? We can try to run it and see if it's going to be successfully run. Oh no, so it successfully bound the socket, right? So creating the socket, bound the socket, and so on and so on. Undefined symbol sysbind. Do DQ and make it 64, right? And every time we sort of like, so it's at the 38. It's at 38. Oh, that's very interesting. Is that because when we do sock of D, we have to... Ooh, this one is interesting. Because it's a double word, and we're okay, I see. It's a double word, but we're saving it to 64-bit register. So what if we just do dq and make it 64, right? And every time we sort of like, yeah, I think that would be better. That would actually solve the problem. So let me see. So we bind, this is 64, and here I will have to use Rax in that specific case. And this is a keyword. Yeah, that would be better. It's actually kind of cool that it checks the sizes. I thought it doesn't check them. Yeah, all right. So it kind of checks the sizes. So undefined simple in address any. Did I define it really? I didn't define it apparently. Okay, so that's fine. So let's say that it's going to be 0. It's supposed to be 0. Undefined symbol sysbind. So let's actually define it. Sysbind. So the error messages are reasonable enough so far. I'm really glad. So let's find the bind thingy. 49. Okay. There we go. So do we manage to compile this thing? And we successfully compile this. Isn't that a poggers? We can try to run it and see if it's going to be successfully run. No, no. So it successfully bound the socket, right? So creating the socket, bound the socket, and so on and so forth.
Mine is binding, but it's printing the success and the error.
right? So one of the things we probably want to do as well is maybe close the socket at the end. When we print OK message, we probably want to go ahead and just close the sock of D, right? So just in case, so we deallocate the resources and stuff like that. Maybe we want to even do that on error as well. So maybe we're going to do that on error as well. But this is a little bit, you know, probably dangerous. Probably not. Because what if you errored at the phase of creating the socket? So you don't have a valid socket ID. How can you close an invalid socket ID? You can't. You can't really close the invalid socket ID. And because of that, close will return -1. But I mean, do you care? It's not going to crash your application. It's just going to tell you, oh, you provided an invalid ID. So what? Right. If I provide invalid ID, it will return -1. If I provide valid one, it will close it and return 0. In both of the cases, it will just do exactly what we want. So who cares? Right? We're not going to check that. I'm not even checking errors for these kind of things. Like, we already got an error. I don't care if this message will go through. I'll just throw it and just die. So I don't think there is any sense in checking whether sock of D is valid or not. Right. So what's the point of checking whether it's valid? If it's invalid, it's not going to crash our application. We're going to continue. We want to forget about this socket ID after we close it. After close, we already assume that it's invalid. So it doesn't matter if it was invalid before that. It just doesn't matter. But it makes the code simpler. Just not caring whether it's valid or invalid makes everything simpler. You see what I'm talking about? Right. Because this is something that I used to fuzz about for a long time, and it would make my code more complicated because I would have to make like additional checks and stuff like that. But if you just say, I don't care if it's valid or not, I'm going to assume that it's invalid after it's closed. So it doesn't matter, just close it. So yeah, I think it simplifies everything. And when you're programming in assembly, you really want to go for simpler solutions because they're going to make your life simpler, right? You're already working with a very terse language, so why making it even more complicated than it's needed? So the question is, will this web server in assembly win in speed a Rust Tokyo web server? This specific implementation, no, probably not. Because to be fair, the performance of the web server has almost nothing to do with how optimal this sequence of extraction is. It's more of a how well you handle the I/O, right? Because it's not really like CPU bound, it's usually I/O bound, so it's kind of like a different kind of problem that you have to solve. So I didn't think so, unless I specifically like work on a better I/O handling. So in the current implementation, I don't think it's going to be faster. All right. So what we're about to use, we're just about to use like a regular reads and writes, right? And it's just like, nah, we're not going to even use send file right now. And people mention IO uring and stuff like that. Yeah, there we go. Okay, go. So we bound everything successfully. After we bound the socket, le socket, we basically said what kind of port we expect from